Hello and welcome to the first episode in this streaming series where I will be creating a game. I just ported the old chess project here, um, so uh, that we are set up and don't have to start all over since I've already built a lot of different nice features. I cleaned up the project and created a new GitHub repo for it. And yeah, I've been contemplating how to do our debugging, drawing all of these meshes, and I want to implement something called instance drawing for um, the whole debug pipeline. So I'll be refactoring that. So in the backend, yeah, I will probably change the folder structure here also eventually, so it makes more sense. I must admit this separation of the CPP and header files is somewhat annoying to me. Yeah, maybe I should say that this project here is called Dr. Man's Rebirth. I have a in paper outline for the project, and I will be filling out the project site eventually, but right now we have these two, what do you call it, project goals. Uh, let's see, the renderer itself is also going to be refactored. So I imagine that the draw debug call here is still toggleable, but I'm pretty sure it's supposed to be moved down here. This shouldn't change much. No. I don't know what's up with that. Anyway. Anyway. Um, so the thing is, I want a kind of like line-based pipeline. Debug, prim, maybe just debug primitives. And we should create a pipeline. Not create resource initialize here. And I imagine something like maybe not even colors. I only think that we want the vertex positions. So let's see. let's create a pipeline state object for that. Dx12 pipeline state debug pipeline. Let's do primitive. So let's do debug line pipeline and rename that for debugging. Because I like to do it from scratch. Okay, so debug line. I think they have their use cases, but if you're interested in engine programming, they are maybe only usable for inspiration or yeah. But most engines are so complicated that you're probably better off just trying to write your own from scratch and failing. Debug primitive pipeline here. And welcome to you both. Yeah. Yeah, it really does. It takes way longer. If you just want to make a game, you could easily use a game engine to speed up a lot of stuff. Well, yeah, I guess it depends on your workflow and what project you're doing. I think for scaling, engines are probably faster. Yeah, I've never tried them. The only framework I use right now is ImGUI. It's just because I did a project here on the channel where I built the UI system from scratch, and it takes a really, really long time to get anything up and running. So we should create a new pipeline here that uses instance drawing. We haven't really used instance drawing for anything yet. Yeah, and let's exclude these. Okay. Let's see. And let me look up the structure here. Yeah, we already implemented the ability to reason about classification. Uh, these questions about what is better is best answered by it depends. It depends on what you want to do and your experience level and yeah, your target platforms and stuff like that. So I couldn't really say that one is better than the other. Oh, which is better for beginners? Well, definitely OpenGL. Definitely. By a long shot. DirectX is pretty complicated. DirectX12, that is. So we have our input classification scheme here. It's already set up. So let's see. We want a vertex and pixels shader. Let's see. Rasterize mode. So use render target preset 2. Let's see. Root signature preset. Thank you very much, and thanks for dropping by. Do we even want nah, we probably want a whole other preset here for this root signature, don't we? Or do we just want to bind? Yeah, maybe we just want not to swap the root signature. Yeah, we could do a combined root signature for the whole debug setup here. So we create a SRV as far as I remember. Since we're gonna use what's called structured buffers, it's basically just regular buffers that you can write to, not constant buffers, which are aligned buffers. Let's see, shader visibility. I need to work on my spelling. Let's just copy this descriptor, shader register. Register space. And then the flex, which will be none. Okay, so we simply add uh, another root signature entry for our structured buffers. Okay, so we create our pipeline, we make it based on instance drawing. Let's see, does everything compile or do we have crashes? We do have problems. Yeah, I need to update the names, of course. Okay, everything still works. Let's do debugging. And let's see. Bind PSO with our commands list here. Let's still set this, and then we will create the index buffers later. Okay. Okay. I'm considering whether I should actually be separating all of this debug stuff into a struct. I don't know. Doesn't make much of a difference, does it? Okay, so we should create some kind of vertex buffer for the debug primitives. We want to create spheres and cubes. Right now, we only draw cubes, so what I'm toggling on and off here, the cubes that, or rather the bounding volumes that surround the chessboard pieces and the meshes here should be um, rendered by instance drawing instead. So let's start out by implementing the cube. So first we don't need the root signature right now. We want to create some buffers. Right now, the engine has the ability to create lines in a vertex buffer that manually handles, or rather handles overflow as far as I remember. Maybe I haven't added buffer reshaping, but anyway, a linear buffer is just a buffer with a write head where you move the write head forward or backwards depending on how many things you actually want to draw. Okay, let's move this. Yeah, This should also be some kind of like, let's arrange this so that it's created in the same area. Okay. Let's do a primitive vertex buffer and index buffer. Okay. We need to update the, yeah. So we create buffers with the size of 64 kilobytes since it's the base alignment of the buffers. So why not just use it when it's allocated? I guess you could map to other parts of the buffer, but yeah, no need to do that. Okay. Yeah, right now we have these. Okay, so let's actually move this. It also has a horrible name. Create debug buffers. Let's see. Let's run this. And let's do the same thing for the other buffers here. Oh, yeah, of course I made a mistake here, but anyway, I'll fix it momentarily. All right, so debug primitive vertex buffer, debug line, and then of course we need to use this. And initialize that. Okay. And let's create a struct vertex primitive. Okay, we create the buffers and I need to correct the mistake I made here. Okay, debug line. Okay, this should be fine. Okay, I still need to Update the names, of course. Okay, right now nothing gets drawn. Let's see if this even gets call created. Debug, vertex, and index buffers. Line, primitive. Oh, we of course need to set that to the index buffer, otherwise we can't do anything. There we go. There we go. Everything is back in order. So we create our buffers. Should be getting console statements that created, debug, line, vertex buffer, and primitive. Yeah, great stuff. And this could actually be moved to the initialization phase here. Now we're only checking for buffer overflow and copying the debug data. Okay. Next, we need a series of structured buffers. And let's see, Directx12 linear buffer here, debug primitive, instance data. And let's just didn't I type that correctly? Huh? Huh? Weird. Oh, wait a minute. Of course. Created debug. Instance buffer, instance startup buffer. I don't actually think I need to create the resource view. Debug instance startup. Okay. Okay. Let's see. So in our renderer here, whenever we create a bounding volume, yeah, I basically want a series of vertices, and this is in utilities. Okay, I could basically do it up here. Create a box, hard-coded. Do we include the utilities? Yeah, we do. Okay. Utils, build indices, or rather, build box vertices from point, radius, padded. Okay, so let's do a point here. All right, buddy. Let's see. Uh, let's do Roddy. Yeah. Whoops. Uh, 0.1. Maybe a very small one. And then let's create a vector of unsigned ints here. Indices. There we go. And then we want to take our primitive buffer destination. Nah, actually, I want to these shouldn't be on the upload heap actually. It's fine since we're probably writing to the line buffer dynamically, but this should be something that the GPU has readily available. I think it's created in a common state, right? Create resource. Yeah, common. Okay. And we will We'll queue in upload from our debug primitive pipe primitive vertex buffer and we will copy from our vertices here. XM flow times the vertices size. And we will queue the indices as well. There we go. And we force our upload service to upload. There we go. Should be fine. And let's do render doc here. Huh. Okay, definitely need to fix that. Anyway, okay. It doesn't like spaces. Let's see if everything then works. Well, it doesn't really run the script correctly. It doesn't run this either. Of course I need to close all of this stuff here. Uh, let's see. Okay. Uh, let's see. Just because. Retarget. I can't remember. Wait a minute. It's because I'm using the wrong version of Visual Studio to open it. It doesn't crash, but I'm unsure whether... Okay, it did update the shaders now. Okay, great stuff. So the build script here doesn't really like doesn't like spaces, I guess. Okay, let's see. So we have a debug vertex buffer, and let's see. Okay. Maybe I shouldn't add the padding here, because maybe I should use the matrices to scale it. Yeah, I think so. Depending on how much we scale, we are also actually scale the padding. And increasingly larger scaled objects would get increasingly large paddings. But we did upload our information here to the GPU. Yeah, let's see. Whoops, this is not. Okay. We upload our information. Here we don't want anything. Padding will be added through scaling. Okay. And let's get the buffers here. Yeah, we already bound the past data. through that. Even though we swap the root signature, the binding is still intact. Okay. Let's just do a simple index count. I can't remember how many indices we have. Let's see. Okay. It doesn't show me. Ref all resources. There we go. It was because I closed the application, I guess. Okay, so index buffer unsigned int. We have 24 indices. So does this draw an box? It probably doesn't. Right now we don't do anything inside the shaders, of course, so we need to add that. Let's see. Vertex shader, pixel shader, and let's open these lines, and this is the lines. I'll move, whoops, move these next to each other. We could basically copy this, except we don't take any color values. Let's just do a float 4 here. Hello, buddy. How you doing? And let's make sure that we force an update. Okay. This should be running primitive pipeline. It should be running no matter what. And if we disable the whole drawing step, but only, okay, we do not get our stuff to render. Well, maybe you'll learn something, maybe you'll get dumber by watching the stream. I can't promise anything. I mean, we're returning a white color that is supposed to be so let me just disable this again. This is supposed to run no matter what. And we do use the debug primitive pipeline. And when we create the information here about the box, let's just try changing this to something bigger. Nope. But we also knew that it wasn't our... Let's see, we do get our indices. Everything got uploaded correctly, so... And we're binding like we should, I think. Index buffer. Oh, wait a minute. Um, if we do something like nah, it's supposed to be around here. Let's try doing that. Yeah. And in the vertex shader, it's not because we flush the This is somewhat weird. So we don't have any errors, so that's great. Oh, wait a minute. We of course need to upload the camera, yeah. Otherwise we can't draw anything. So that's why the black screen doesn't work, at least. Okay, maybe. Okay, let's just. Maybe it's inside something else. Maybe it's occluded or. So. Create the chessboard. Let's not draw the first tile. And I'll still create a box that is a bit too big. Let's see. We can always just look up the debug information inside the render doc. So let me reset this back to a cube, compile it, run it in render doc. Let's see. Float 3. Yeah, so we have a box that have these 8 corners. Okay, let's see. Let's see. Okay. So this is the problem. Our mesh here It's all the same information during this draw call here. Vertex 1, index, blah, blah, blah. Yeah, so I'm doing something wrong here. Oh, it does create something that is somewhat weird. Uh, no, it's an adaptation. I've created the base engine in another streaming series, and most of the code is replicable. Okay, so I'm thinking that the input signature is the problem here. Let me see. No problem, man. Let me see. I need to fix the input layer, I think. Let me see. Um, Let me swap. Of course, create one instance here. Uh, Maybe we don't want to have a per instance uh, based. I think this is probably more suited for something like a decall buffer, or rather renderer. Yeah, there we go. That's the problem. So, yeah, I told the input assembler to do something. No, I haven't actually. I've created an OBJ parser. Um, I don't know if I actually discussed it here on the channel, but let's see. Where did I put it? Resources, maybe? No, I can't remember where I put it. Data structures. Oh yeah, yeah. So I've created a OBJ reader, but you might be able to either download one or build one yourself. There are some, I don't know, tutorials I think on it. I just built mine from scratch. So I actually don't know the resources, but I think there are some repos where you can find an OBJ reader, where you can translate it into a vertex and index buffer uh, format. Okay, so let's see, when we create our debug buffers here, we're back to wanting a small box. No problem, man, and good luck. Okay, so we have our basic bounding volume centered at the origin. Next, we want to bind the structured buffer. So this is our debug primitive. Let's do a structured buffer with a temp. No, instance startup. Instance startup. And we will grab it from the T0 register. Redefinition. Oh, wait a minute. Buffer. And we will create a float 4 here called position, which we will do. Let's do a float 4x4 matrix transform and a float 4 color. And we will actually add a, not it to our input, we will add it to our output. Float 4 color, color, instance buffer, and we of course need our instance ID. So unsigned int instance ID, instance ID here. dot transform. Let's call it, what do we call it in our polygon shader? Transform, okay, that's fine. And we add on 1, so we get the translation as well. Okay, so right now this won't work. But no problem, man. I'm glad you enjoy it. And I'm happy to be able to help. Feel free to ask questions during the streams or join the Discord channel. There's a lot of guys doing stuff over there in terms of learning graphics programming and so forth. Okay, so goddamn autocomplete. Right now we will set our color to okay. Yeah, so we bind our structured buffer, and we of course use the information inside that structured buffer to render our primitive. Right now it's empty, so we shouldn't. Okay, at least we saw that our shaders updated and we have the color change right now. Let's see, did we? It's because we override it. Okay, so now XYZ here. Yeah, now we won't see the object because the structured buffer doesn't contain anything. Let's see, rendering types, object data, pass data, struct debug, primitive, data. We will create a transform. We will create a color, which will be white as default. Okay. And let's create something like this. There we go. And let's create the scaling here. Okay, and let's upload it to the GPU here. Well, basically we don't need to. We can just do copy since this buffer here is on the dynamic heap. Let's see. Whoops. We need to initialize the instance buffer here. And let's reference our temp information here, size off, debug primitives. Okay, we copy the temporary matrix. Great stuff. And let's bind the structured buffer here. Set, whoops, graphics. Set root descriptor shader resource view. There we go. And it's the index like that, and then debug. Get virtual address. Right. And there we go. Immediately it uses the instance data. And if we increase this to 2 and add a second instance to our buffer here, let's do a by pointer from our thing here and add size of debug primitive data, and then create another one. There we go. We should now see 2. Yeah, we do. Great stuff. So we basically have instance drawing now. And we can start porting our system. And let's do a let's do a struct Directx12 debug prim call instances. Cube instances. debug primitive calls. Okay. Yeah, I'll rename that. Okay. Cube draws. I'm even pretty sure I can offset this manually. Yeah. So I could probably use the same buffer for both spheres and boxes. Okay, so we're set up. And then let's create a way to actually draw the debug stuff. Okay. Draw debug. Let's create a method that is able to do let's see, a mesh buffer, position scale. It will eventually have rotation, mesh as well. It's fine. Okay. Game, mgame state, mesh buffer. There we go. So our debug information should be gone, but that's fine. We can add, by the way, that one back. Oh, it's in the mesh submission here. Okay. Okay, draw debug. And let's do a void upload draw debug draw data. Unsigned int boxes const unsigned int spheres boxes. Okay. And let's re-enable the two things that we actually created up here so that we can see that we actually draw something. Yeah. And this will of course only draw one. Size. Let's see, do we even get any performance of it? Yeah, so the plan is to actually upload the well, what do we want to upload? We want to upload a series of primitive calls. Maybe a yeah, maybe a struct Directx12 debug draw packet. And let's see. Maybe this is not the solution. We don't need the. We kind of like need a. I mean, this copies our information and creates the draw calls, copies over the constant buffers. And that's great. Um, um, but since we have instance drawing, we do not need separate draw calls. We basically just need a number. But we would want to handle the buffer data. So we need a sort of method well, this is probably fine. And then we could pass in a vector of pass in a series of a vector of this is all packaged together since it's not instance drawing, but this is okay. So but I don't want to force the yeah, I don't want to force it. I want to separate it out. I only want to do it sometimes. Create debug draw calls. Okay. let's do a method update debug data. Yeah, we could eventually combine them, but we aren't right now. Right now. Not draw packet Directx12 debug. Pyramid data. And we could still do something like const unsigned int, copy these two, since we might want to actually do lookups into this data here, depending on those values. Okay. So for unsigned int I equals 0, I less than boxes I++. Yeah, basically we don't need those calls, but we will keep them separate for now, but we definitely didn't. Okay. It's basically the same data structure. Where is it? Rendering type. Is it just what we want instead? We can do like that, I guess. And just do one mem copy from the not rather to the debug primitive instance data buffer get memory from the primitive data for size of okay. Okay. Okay, we need to enter the debugs namespace debug primitive here. Wait a minute. Whoops. Or what? No, that's not the right one. Oh, I'm messing up here. And where does this other thing here get defined? Rendering types. Oh, the other one is resource types. Okay. Oh, wait a minute. Okay. This is going to be deprecated for now. Actually, I think I'll disable this one. And let's use the correct type then. There we go. Primitive data, pushback temp data. There we go. Okay. Let's do. Yeah, I'm not sure it's supposed to be like this then. But we will keep it for now. Console auto reference. Draw. Okay. Let's update the draw package here to have Uh, uh, ST matrix. Let's do an XM matrix. ST. No. XM matrix R disabled right now. XM matrix T is equal to and we will save the store float. 4x4 here. And ST matrix, it's because we will support rotations in the future. So needs to be SRT in final version. ST matrix here. Yeah, so we store the unrotated matrix on the CPU side. It's fine. And then we can actually we could change this to a pointer. ST matrix. Let's do a red color for now. Okay, so Let's see, what's the problem? Uh, hey Bob, how are you doing? Mm. Oh, oh, that's why. Okay, okay, so this should be okay. How are you doing, buddy? But then we need to actually. Okay, maybe it's better just to copy the data. Okay, I'll copy the data. Oh, I'm happy to hear, man. What have you been up to? All right, we're getting somewhere. Yeah, so the problem is our basic uh, Um, let's create a oh, where we ask for the times the y and then the z-axis as well. And double it, I think. Okay, let's try that. There we go. And we're back to actually having what do you call it? Bounding volumes. What have you been up to, FTC? If you're still here. Well, there's a problem with the color. Oh, wait a minute. We don't return the color, do we? Can't remember. Yeah, we do. But do we? Yeah, we hard-coded it. There we go. And inside this, I think we should reset the draw. Yeah, okay. So now we have instance drawing for that. Let's create the base color, which is going to be green. And let's reset, or rather use this logic here. Okay. Okay, so this should yeah, instead of allocating this all over, our renderer here does have some kind of frame data, debug packets, debug data. Yeah, okay. For debug primitives. Let's disable this and primitive data. Yeah. It's not gonna do anything, but and up here. And it's created when the application is, yeah. When is this called? Is it during the create game thingy? Yeah, it is. Okay, so we build them, but it should kind of like be deprecated this function, and we of course create the information. This is also something that we probably would deprecate. We could do something like frame data. Okay. Maybe one. There we go. So we create the information the first time. Uh, okay. Next we need to let's disable this. Okay. Yeah, it definitely doesn't matter much now whether we toggle this on and off. Okay, so let's see what happens. Okay, yeah, we don't update the thingy. But what happens if we... Okay, it does get removed. Interesting. We could just do something like a flush, I guess. I mean, debug select. Game state, debug select, game state. Okay, and inside here, there we go, and we're following around. Great stuff. Okay, so that works. We simply force the flush on selection. Uh, yeah, let's just enable this again. Uh, wait a minute, we don't know what object it is from the selection index here. Okay. We actually don't know that. Okay, so maybe it doesn't matter too much. So whenever we submit this, could we do some kind of no. Yeah, maybe we don't want any maybe we don't care. Yeah, maybe we don't care about this selection stuff. Maybe we just want to update if we actually selected anything. Right now we don't care too much about that functionality. Great. Everything still works. We have if we clicked anything. Okay. I don't know. We could of course add some kind of selection flag, but I don't know. Doesn't really make sense, right? I mean, maybe we just want to do some kind of yeah, we could of course create some kind of like other visual cue. Okay, this needs to be deprecated. No, not deprecated, simply just removed. This is also not needed. Okay, we cleaned up the rendering API. This is actually not needed. And inside the game state stuff, right? Yeah, of course we need to. Oh, I need to remove this before we can actually see the effect. Okay. Okay, we cleaned it up. Um, Hello, buddy. Okay, so we have actually created what we wanted to in terms of creating instance rendering. Next step is to add different decals. Right now we draw a AABB around each mesh. Yep. I wonder how much this costs us. Probably not a lot. Anyway, I think I need a break. But we definitely got some progress here in terms of refactoring the debug stuff so that we can actually do debug primitives. Yeah, I need to figure out some kind of nice way to recolor a AABB bounding volume debug primitive thingy. Um, Also, yeah, this supports. So this builds the debug information from the actual renderables, which we calculate up here. I guess I could do it down here. Okay, let's try doing that instead. Let's move this out of the packet thingy. But I guess okay, if we do something that is quite hacky, but I mean, we could reference the yeah, we could actually move this. Okay, so instead of the packets actually containing the AABB matrix, we decouple that. Does this know about the Rendering types. Resource types. Mesh. Okay, it does. For debugging, we could add a mesh pointer perhaps, but we never use this, right? Renderable mesh. It could contain a maybe a renderable mesh and a mesh pointer. Instead. Okay. Let's do a reference to the drawable here. This should be fine, right? Let's disable this for now. Also this one. This should be fine, right? No, not yet. Let's see. Let's see. Packets. There we go. Yeah, the compiler probably skips this. Okay, so let's disable this. Let's disable this, and let's disable this. Okay. We update the, or rather we set a couple of debugging pointers here. It's not great, but that's what we do for now. draw mesh. Like this. Okay. Wait a minute. There we go. Let's see, does this... I think we got more performance here. Yeah, this shouldn't calculate uh, some dangling pointers potentially. Uh, okay, so now we don't need to do the computations for the AABB matrix. Yeah, I think that's better. Anyway, I'm gonna end the stream. Yeah, thanks for tuning in and interacting. It was a real pleasure. I'll be continuing the series here on the channel in the future. All right, please take care, everyone.